Hello and welcome to the channel. This is one of the simplest problems from American Region Mathematics Leads competition that took place at the 4th of June this year. I must admit that the list of participating countries is rather unexpected, given that only USA, Canada and Colombia represent American continent. What is really sad, neither Australia nor New Zealand appear among the countries. Please don't take it as a judgment about the level of mathematical education as a green continent. Now to the problem. The difference of two cubic roots is equal to 2, and you should find only a real and positive value of x satisfying the equation. Hopefully no other hints will be needed for solving, so please pause the video and try to solve the equation. Let's start with a straightforward way of solving. To do that, we just isolate the first term, moving the second term to the right hand side. Now we can erase both parts of the equation into cube. Note that raising into an odd degree doesn't give extra real roots. Now we simplify the right hand side expression and see that 20x at both sides can be cancelled out. So x remains only under cube roots. This suggests substitution. T equals cubic root of 20x minus 22. So we apply the substitution and move 22 to the right hand side, where negative 22 and negative 14 add up to negative 36. We've got a quadratic equation for t, where all the factors are divisible by 6. So let's reduce it by 6 and write in a proper way. Since t has an even factor, we can use the simplified formula for the roots of the quadratic equation and find that t equals negative 1 plus minus square root of 7. For better readability, let's write minus before the brackets. In order to avoid possible criticism, I changed plus minus to minus plus. However, this isn't really essential. Now we can get the equation for x using the expression for t, and we raise it into cube and find the value of 20 times x. Remember that we are looking for positive values of x, in which case 20 times x is also positive. Since square root of 7 is greater than 2, 1 plus square root of 7 is greater than 3. Therefore, 1 plus square root of 7 cubed is greater than 3 cubed, or 27, which is greater than 22. This means that if we take plus before the square root of 7 in the right hand side of the expression for 20x, the right hand side becomes negative, which we want to avoid. Therefore, the sign before the square root of 7 may be only negative. Now let's clear the page and copy the obtained equation to the top. For convenience, we replace minus before the brackets with the plus and reverse the order of terms in the brackets. Now let's expand the brackets by raising square root of 7 minus 1 into cube. And we simplify the obtained expression and reduce common terms, and are left up with just 10 times square root of 7 for 20x. Therefore, x equals 10 times square root of 7 divided by 20, or just square root of 7 over 2. This is the answer, but not yet the end, because I am also going to discuss the official solution, which is as usually shorter and trickier than my own. Let's use letter m for the first term and letter n for the second term. Then the given equation can be written as m minus n equals 2. And we raise the equation into cube. Now m cubed minus n cubed can be written as 20x plus 22 minus 20x minus 22. After expanding the brackets and reducing common terms, we get just 44. For the two remaining left-hand side terms, we can factor out negative 3mn and replacing m minus n in the brackets with 2 gives negative 6mn. Now the equation for m and n can be rewritten as 44 minus 6mn equals 8, from which it follows that mn equals 6. Now, since we know the values of m minus n and m times n, we can find the values of m and n and then the value of x. However, there is a trick that allows to find the value of x straight away. So we can write that mn cubed is 6 cubed or 216. On the other side, mn cubed is m cubed times n cubed, or 20x plus 22 times 20x minus 22, which is the difference of two squares, 400x squared minus 484, and all that equals 216. So we've got an equation and find the value of x squared, which is 7 quarters. And since we are looking for a positive value of x, it must be equal to square root of 7 over 2. We've got the same answer as before, but in a much shorter way. And this is the end.